Allow me to break some hearts for a minute here. We got a rear-wheel drive Infiniti sedan, for example, and so you have a pumpkin in the rear that transmits power through those axles in the rear wheels. That's called a differential. Unfortunately, or by some design, since 2002, the flagship sedans have not had any form of limited slip, no viscous LSD or anything like that. So they are open diffs, right? And people usually ask, well, if I don't have an LSD, I don't have a posy rear end, how come whenever I'm doing hard launches, whenever I'm doing burnouts or something like that, I leave nice even patches behind me? I attribute that to two reasons. One is the purpose of a differential. A differential is supposed to allow for difference in speed between the left and right wheels when you're going around a corner. Makes sense, right? The wheel slip is just part of, part of the game. So if you're going in a straight line and both wheels have even traction, there really is no need to see your wheels slipping, right? So yeah, it's going to look like a limited slip when you're going in a straight line, right? Anyway, check this out.
Let's talk about the alphabet soup that makes up Nissan or Infiniti's vehicle dynamic instability control systems. You have these words: ABS, TCS, VDC, slip, as well as EBD. It's not one you see often, but we'll mention it here. But before all that, let's sketch a car, the main systems of a car. If this is an Infiniti, we're talking about the rear-wheel drive vehicles. Let's put a differential in the back, because the rear, that's where the drive wheels are. This is the front of the vehicle. And now, well, you have brakes in here. You need a way to start. You need a way to move. You need a way to stop. You have brakes in there. All right. Now we'll go back to the other page. Well, let's label this. That's a diff. And just a quick overview of the differential. A differential allows the rear wheels to turn at different speeds. For example, you're cornering, and if your corner is aggressive enough that, say, you want to make a quick U-turn pivot like this, right? So this, theoretically, this wheel will be turning at 0 miles an hour, while this one here will be making a complete circle, or well, half circle in this case. So that's what a differential allows you to do. There's a really good video by GM, one of the older videos by GM. I'll link that in the description so that it can explain why you need a differential and how a differential actually works. Okay, and I'll put LSD here. We'll come back to that. We'll explain that later. Okay, so let's jump back to the other side, okay? First thing we're going to talk about is the ABS. As you can see, the letters come from there. Anti-lock braking system. The purpose of the system, as hinted at in the description, is to prevent locking of something during the process of braking. So yeah, so let's explain what happens here, right? So typically, you're rolling down, right? Your rear wheels just basically, let's put some silver here so that we can kind of give it some direction. Some chevrons, right? You're rolling, you're going, this is normal motion, right? Your wheels are just going like that. Your wheels are going like that, right? The front wheels are the ones that will be turning, so while rolling, you turn them. And this is probably an experiment you've done. It's easier to turn wheels while you're rolling than when they're stopped, right? Because you just kind of use its own momentum to keep going, right? So when you hit your brakes, typically what happens is that for your braking system, right? One, you have your pedal here. Should I really draw that? Let me skip on to your master cylinder here. This is what keeps your fluid. And somehow, brake fluid has to be sent to each corner, each wheel, or each axle, if your car is braked by the axle. And what happens is fluid is sent to each corner, right? Fluid stops at each corner. And if you happen to slam on your brakes, the whole purpose of braking is to stop this motion, right? The whole purpose of braking is to stop it, Well, typically your calipers will gradually bring this to a halt, so it's not gonna, when you hit the brake, it doesn't skid like that. It slows down, right? Then it finally stops. That is how it's supposed to work. If you hit your brakes, such as in a panic, you'll probably hear screeching, and you might smell smoke, you might see smoke. That is because when you hit your brake so hard, this just stops, and basically the rubber has friction against the road, right? So that's what happens. The problem is that when you do that to all four corners, right? Remember I said you steer easier when the thing is rolling, right? It's easier to turn this and get it to steer, right? So when you do that and you lock all four of them, basically, say you were turning with your front ones, right? And you lock them, what happens is this. It becomes a rubber, it's like a puck. It just skids forward. It goes in that direction. Because at that point, all you have is those four square contact patches, right? Your wheel is not doing any rolling at that point, right? Your wheel is not doing any rolling. So the purpose of the ABS system, let's label this, by the way, MC for master cylinder. The purpose of the ABS system is to prevent that locking in a panic. What it does is it locks, releases, locks, releases, locks, releases. And again, you're going to use that advantage of the moving. During the release, the motion will allow you to steer, basically. So let's say we're going down this way, right? And we hit the brakes. That's just going to keep going straight because that's all it is at that point. However, if at some point you release it like that, it's going to allow the car to go that way. So that's what the ABS system lets you do. The ABS system prevents locking of your steering wheels in an emergency stop. So how does it enable that? You have what is called an ABS module. And that module basically tells, or rather controls, modulate is the word. It modulates the amount and the pressure of fluid that goes to each wheel, depending on how hard you push your pedal. There's something called a thrust sensor under your pedal that senses how hard you push your brake, and that's what makes your seatbelt grab you. Anyway, that basically gets signals from around the car, and those signals are sent to each wheel. Those signals are sent to the ABS system, and then the ABS system modulates how much fluid goes in there. Basically, it puts fluid, releases, puts fluid, releases, and that's how it brakes and releases your car. So for the ABS, we talked about the anti-lock braking system, and during operation, right, as I said, it's a pulse, it's a catch release. You will usually hear this ABS module making mechanical noises like vibrating, buzzing.
Also, because the brakes are being applied aggressively, you might hear some slapping noises. That is due to the brake pad being slapped against the rotor.
Not only that, because you have fluid kind of dancing around in here, your pedal might vibrate as well, pulsate as well. So those are the things you'll see when it's in operation, right? And typically it's a behind the scenes thing. You do not see any lights, any indication in the system. If you do see your ABS lights, you got a problem. All right, just want to put that out there. However, and I want to say, when you have a problem with your ABS system, in these cars at least, what you see is the ABS light, VDC, and slip. All right, maybe I should well, I'll come back to that slip later. All right, so that's what happens. Let's talk about TCS. This is the traction control system. And so what the TCS system does, right? So I mentioned that you do have your wheels here, and I drew the differential. The traction control system, as it says, is to measure traction, basically how well am I rolling on the drive wheels. The traction control system focuses on the drive wheels only. That is, and how does it know what the drive wheels are doing? It uses wheel speed sensors. and these are the pickups. They're just basically things that look like little gears over here. And then you have sensors over here. Some people call them ABS sensors, call them wheel speed sensors. And those basically tell you what each wheel is doing. So the TCS system monitors the rear wheels. And if one side is, if one side is spinning faster than the other side, it says, hey, could you stop that wheel for me? And then it communicates with the ABS system, and the ABS system locks that wheel. And then, traction goes to the other wheel and whatnot. If both of them are spinning faster than the front, well, the car says, we got a problem here. Something's going on because we're just wasting power in the back and the car is not really moving. So what comes in is torque management. The torque management of TCS system, basically that cuts power. Okay? So let's note that somewhere. Let's note that the ABS system, ABS, brakes or prevents braking, brake lock. It mostly is focused on the drive wheels, in the steering wheels, and most times when you're braking, most of your braking force goes to the front, so you'll see those catch and release. However, that's a bare bones part of the ABS system. However, the ABS can work on every single wheel. We'll get to that later. TCS, rear wheels. It's about drive wheels, basically. Let's put it like that. So, and also torque or engine power, engine management. All right. In conjunction with the ECU, this is basically the one that runs the whole engine. In conjunction with that, basically it says, hey, we're sending too much power in the back, and this thing is going to keep spinning if we don't do something about it. So one part of it is that the ABS system kicks in, and when the ABS system kicks in, the slip light will be flashing. That's probably the only time you want to see the slip light, flashing. And when it's flashing, it tells you that, hey, we're doing some braking in the back, right? So that's going to stop that. And then the engine management part of it, this is the non-fun part of it, is that it cuts fuel. Basically, you can have your foot all the way to the your foot on the gas all the way to the floor, but the engine's not going to go anywhere. For these cars, it's 1500 RPM. That's where limits your fun to be. 1500 RPM on the So let's come back to this differential thing that I was talking about earlier, right? So the differential is supposed to allow your wheels to turn at different speeds, right? Even the front ones, by the way, sometimes have differentials, and you have differentials in the center and all that depending on the configuration of the car. So some cars, sports cars especially, and high performance cars come with a limited slip differential. What that aims to do is typically it's mechanically, there's some electronic ones, equalize the speed on each side of the differential, right? That means if this side starts spinning, the other side should be right there with it, right? So that you don't, typically the way open differentials like this one is, the way they're set up is that if you don't control for anything, all the power is going to go to that wheel that's spinning. But differentials is, as I said, part of a different deal. I'll leave that for later. We're going to talk about that later. So what this system does here, the TCS system, the traction control system does, is it does its best to simulate a limited slip differential. It is not exactly an electronic slip differential because it does not electronically lock your differential. The difference is it doesn't just seek to equalize. It seeks to put power where it is. So for example, if you have this wheel on ice and this wheel on pavement, naturally power will want to go to this wheel that's on ice and keep that slipping, right? This wheel is not going to move anywhere, right? So what the TCS system seeks to do is, one, limit how much power is going there, because if you send so much power, it's just going to keep spinning. If you send a little power, it's easier to regulate that. It locks this wheel using the ABS system, and as a result of that, the power that's coming down from the engine has to go somewhere. goes to this wheel, and since this wheel is on pavement, it goes. So that's the part where it kind of works like a limited slip differential. It does not equalize the speeds, it just sends traction where it needs to be. Okay, so we'll jump over to the next definition. We already talked about slip, right? I said that's just it's an indicator. Cool. Let's skip the VDC. Let's talk about EBD. EBD is electronic brake force distribution. Don't have to be very good with words to figure out that this is about sending braking force wherever it needs to be. So we kind of covered that a little bit, right? EBD. Now this one is about all wheels. It's about sending brake force where needed. Let's label it like that, where needed. So in that system, I explained that the TCS, right, will send braking force to the rear, right? It monitors the rear, and it stops them from spinning, right? EBD explains that concept, where if force is needed to brake this one wheel, the EBD system says, hey, send it right there. Okay. What I did not label earlier was that the front wheels also have, well, first let's just mention the differential here, because I did mention if they're spinning at different speeds, and I did not really mention how you know that. The front wheels usually have wheel speed sensors mounted, on the bearings as well. So, pardon that. So, EBD basically sends power where needed. All right, so let's look at another extreme example. I'm going at 60 miles an hour, and for whatever reason, I need to bust that UE that I talked about, a really sharp U-turn, right? Like that. Okay, so what happens is, hypothetically, EBD will say, hey, from what this dude seems like he's asking for, is we need to lock this one right here, because you need to pivot all the way and go backwards. So EBD, hypothetically, will not brake this wheel at all, because this wheel needs to turn as fast as possible, as freely as possible. Probably does not need to lock this wheel, because again, it's able to turn sideways, right? So EBD will send 100% of braking force here. I don't know if it's really 100, but it sends a lot of it to the wheel that's needed. EBD, again, communicating with other modules, tells you, hey, this is where it's needed. So it will lock this wheel, and you'll be able to turn, and when you straighten out, it releases that wheel, and you're able to go at whatever speeds you need. Here's another example. If you're going down, you're going, an on-ramp or whatever it is, but you need to turn right aggressively, right? Remember, I said in the beginning that when you're going forward and you start braking, most of your brake force goes to the front anyway. So even if you lock the rear, they're just going to skid. They're not really, not much contact with the road. So what happens at that point is that the car senses that, hey, you're trying to turn this way, and you don't really need brake fluid to be sent to the back, so it's going to brake this wheel right here, right? So it's going to brake this wheel to allow you to turn this way, right? Does that make sense? It's intuitive, right? So that's what EBD does, and EBD is used in the modern cars for lane departure control and stuff like that. It brakes, EBD basically sends it where it's needed. So if it needs to brake this wheel to be able to bring the car back into the lane, that's what it does, right? And that's a story for another day. But basically, the lane departure warning systems for conventional steering wheels, they use the brakes to bring the car back where it needs to be. It makes sense, right? If you're going straight and you brake this one, well, that means the car's going to start turning this way, right? If you're going fast and you start braking this wheel, the car's going to start going this way. Anyway, so that's where EBD is. Let's talk about VDC, because that's kind of, after you give, all these systems kind of matter in a way. You don't really see that one. You don't really see it show up anywhere. But you only have a button for VDC, right? VDC is Vehicle Dynamic Control System. And VDC basically is a combination of TCS and ABS and EBD and everything else. VDC is your smart system. VDC is what combines everything together, right? So back to our drawing here. What VDC does is monitors every single wheel. It also monitors what the car is being demanded to do. So for this, we'll add a circle here. That is our steering wheel. I should have drawn it with a flat bottom, huh? Anyway, that's your steering wheel. And the component in the steering wheel that actually is monitored is called a steering angle sensor. That's the thing that when it goes out, it gives you all this other VDC reactive steer, depending on the vehicle make and model, right? So steering angle sensor, again, remember, I want to reiterate that it's not in a refined car, in these flagships, these big luxury sedans, at least the way Infiniti makes them, it's not about equalizing and being aggressive and all that. It's about refinement. So for example, if I turn this steering wheel to the left, I want my car to go left, right? If I'm at speed, your limited slip differential wants the wheels to go at the same speed. However, in reality, this one should be slowed down a little bit. What the VDC does basically says, hey, is your steering wheel straight? That means you're trying to go straight. That means we'll try to equalize, not really equalize. We're trying to make sure that you go straight, right? So what it's going to do is that if this wheel is on ice, right, what it's going to do is this. It's going to drive this wheel that's on concrete, right? But since your wheel is going straight, it's sensing using your, I need to add those here. You have yaw sensors and G sensors that can tell whether you're turning, whether you're understeering, oversteering, drifting, or something like that. So let's add that. Yaw sensor. I'm going to put a huge G in the middle. Well, it's also called a G, lateral G sensor. That's what it is. But as I said, that's called a yaw sensor. Yaw sensor. And basically, yaw is this motion right here, right? So this is a vehicle or a boat, right? That's where it comes from. The sideways motion, that's yaw. G is more sideways, right? So this guy senses what the car is doing, and it communicates with what the steering wheel is asking for. If you're trying to turn left and this thing is not moving at all, it says, hey, we're not moving. What's happening? We're supposed to be going sideways, right? As an example. And so, and I'm leaving out a lot of pieces here because you also have your brake pedal sensors. You have your multiplier pump. You have so many components here, but I just wanted to touch on the basics and what they do. So your VDC system, as I said, it's a combination. So your VDC system does everything. This, as I said, is supposed to be a smart system. That's what converts your big vehicle into a luxury cruiser, basically. It's crazy. You don't really think about it, but these cars are really smart. They do have a lot of technology in them. And so, as I said, the VDC controls everything, and what that's supposed to do is pretty much keep you stable. Remember, the thing is not about keeping you straight, keeping these straight for racing or anything. The thing is about keeping you stable. So VDC makes sure whatever it is your steering wheel is asking for and your gas pedal is asking for, that you get it. The only part that sucks about it all is that you cannot control, once they start kicking in, is that the TCS component of VDC will start cutting fuel to 1500 RPM. And again, I'll try to get a video of that. So what happens and whenever you see the TCS component happening, that is the braking, right, of each wheel, again, slip light will be flashing. So you do want to see, if you do see a slip light flashing, do not be afraid. Let it slip, basically. Let the car do its thing. And just like any other system, you actually don't try to modulate, don't try to get on the gas and release and do all that. Just get on the gas moderately, don't floor the car if you're trying to just go a short distance. but it actually needs to slip to know that, hey, this is what we actually want to do. So if you keep getting on the gas, let go, getting on the gas, let go, the car doesn't really understand exactly what you want to do. I needed to add something here. The VDC system, when that's faulty, what you usually get is a VDC light as well as slip. As I said, when you get those solid, you get a problem. You only want to see them when they're flashing. And that actually reminds me of the other things that, how all these lights usually show up for different problems, like the steering angle sensor, right? Call it a SAS. You will see a VDC slip. Depending on what kind of car you have, you might see AFS, you might see the reactive steer, right? And then whenever you have brake fluid low, you usually see something like VDC, TCS, and ABS, if memory serves me correctly. But I just wanted to kind of touch on that and let it, be a brief introduction as to how these systems are supposed to work. And for me, my preference is usually to just leave the VDC switch on. That means you don't touch it at all. It's one of those, it goes back to, it's a return position switch, and it defaults to on every time, because really the goal of this system is to make sure you don't crash and you have a refined driving experience. I know some people usually go ahead and try to trick it, but you could turn it off, which is temporary, but some people actually cut this off and cut the signal here. But that's a story for another day. That's how people go drifting. Personally, I wouldn't do it with an open diff, because you're really just messing it up, the spider gears and all that. But as I said, that's a story for another day. All right, I hope this video is somehow helpful, as well as the other one that will come later.
In conclusion, these electronic stability and traction control systems are very fast, smart, and wonderful. They make anybody look like a pro on snow. However, you cannot be too complacent. Remember, at the end of the day, you're the ultimate custodian of your own safety. You cannot fully depend on these systems because they could fail. But not only that, you cannot break the laws of physics. So if you go around driving like a fool on ice or snow, you will probably end up in a ditch or around a tree. I hope these videos are somewhat useful. I hope they explain the ins and outs of your car in a basic sense of it. And I hope they help you enjoy your car a little better. All right? Be safe out there.